Today's lecture, we are going to do past papers of energy, work, and power, and 2021 whatever, and 5054, which is the code. Okay, so let's start. So the first question is: the diagram shows a block of mass m pulled in a straight line along a horizontal surface by a force F. The block moves a distance d in time t. The average speed at which the block moves is v. Which two quantities must be known to calculate the work done? So basically, it's asking that first that that what two quantities should be known to find the work done. So work done is equal to F into D. So it means that force and force and distance should be found for work done. So in this, what is the force? So mass M is pulled in a straight line by force F. So F is the force. So we have to find F, and with it, the block moves a distance. So we are here is the distance, D is the distance, and F is the force. So F is the force and D is the distance. So we have to find F and D. So A is the answer. Okay, A for this first MCQ. Now let's go on to the second MCQ. In this MCQ, what's the question? The question is a 60 kg ice skater traveling initially at 3 meter per second glides across a horizontal icy surface. The skater brakes and comes to rest after 5 meters. So the work done against the braking force is changed in the kinetic energy of the skater. Okay, so it means is the change in the kinetic energy of the skater. So it means first we have to find out the kinetic energy. So what's the kinetic energy? Kinetic energy is equal to 1 upon 2 mv square. Okay, so what is the m? M is m is 60, right? M is 60 and v is what is v? Yes, yes. So the v is 3, right? So 1 upon 2, 60. Okay, let me check it in the calculator. So wait, 1 upon 2, and it's yes, multiplied by 60. Wait, let me check it in the So the answer is 270. Okay, so kinetic energy is 270. So what is the braking force? So the braking force means that we have to find force, right? And the distance is given, right? And kinetic energy means energy, or energy also can be work. So work means work is 270 joules. Okay, we have to write this unit because it consists of mass. Okay, so means that W is equal to FD, right? Formula is this. So we know that W it is 270. So we have to find F, which is unknown, and distance is 5. Okay, so for finding F, what we have to shift this 5 over there, and 270 upon 5, which is equal to F. So let me check it in the calculator. So the F is 54. Okay, so let me check if there answer any. Yes, yeah, not 18, not 37, yeah, and so it means that C is the answer. Okay, so for question 2, C is the answer. Now let's check question number 3. Which equation is used to find the efficiency of an energy transfer? So this is an easy question. So in this, what do you have to find the formula for efficiency? So the formula is efficiency for the formula of the efficiency is that useful efficiency. Okay. So what's the formula? It's useful energy output upon total energy input. Okay. So can you see anything like this? So in the first efficiency, you will be useful energy output. Yes. So I think A is the answer. Let's check B. Efficiency total energy input. No, it can't be this because from the above it's useful energy output. So A is the answer. Let's not waste the time and let's go on question number 3. So in question number 3, there is a question. In a coal-fired power station, a coal is burned and electric energy is produced, right? State the form of energy in the coal that is transferred to electrical energy. Okay, okay. So the form of energy in the coal. So what's the form of energy in the coal? It is chemical energy, okay? So this is a factual question. Chemical energy. So this is the chemical energy. Now we are done with this. Now there is a question to state the principle of conservation of energy. So the principle of conservation of energy states that energy can be neither that energy can be neither be created nor destroyed, but it can be converted from one form to another. Okay. So this is the principle which is very famous. So let's write the answer that energy can be neither be created nor destroyed. Okay. But it can be converted from one form to the other. Okay. So this is the answer for this question. Okay, we have to write the principle of the conservation of energy. So now let's do the other part. The quantity of electrical energy produced by the owner by the power station is much less than the quantity of energy in the coal that is burned to generate the electricity. Explain why this is so. So the two reasons are that because heat energy is produced in this reaction and light energy is also produced. So basically, the chemical energy of well, of the coal is transferred to heat. Okay, plus light energy. Okay, hence and also there is friction, right? So hence and with it there is um there hence there is hence the energy is distributed in these three factors, so that's why the full potential of energy is not being uh is not being applied in the further. Okay, so here's another question. State one environmental consequences of generating electricity in coal fired power station. So for the answer will be that in coal, if we observe coal, when it is burned, it produces smoke, right? And that smoke contains CO2, right? So this CO2 makes air pollution. So the answer will be air pollution. This it will be air pollution. So now let's go on question number five. The work done by force F on a body is calculated by multiplying F by quantity Q. What is Q? Okay, so what is work done? Work done, the definition of work done. Work done basically means that when force is applied on a body and that body moves in the direction of the force, that is called work done. Basically, the basic definition of work done. Okay, the physical uh, definition of the work done, while the theoretical definition of the work done, while the mathematical definition is that F into D. This is the mathematical definition of work done. So in the theoretical definition, there is in the second part, it consists that the distance traveled in the direction of the force. Okay, so no, so hence because it's F into D, right? So D will be the distance. Okay, because F is the force as it is said force F in the body is calculated by multiplying F by a quantity Q. Okay, so Q is the distance in the direction. Okay, so the first option is the distance traveled in the direction of the force. Yes, this is our option to be noted. Okay, the distance traveled perpendicular to the direction of the force. No, because in perpendicular energy won't be the energy the distance can be because that is the gravitational potential energy. Okay, so the velocity is not included in this. So hence C and D are not correct answer. Okay, so some solar panels have a total area of 12 meter square, right? Each 1 meter square of the panel receives 0.485 kg of energy from the sun in 1 second. The efficiency of the panels is 16%. How much power do they produce? So in this, what do you have to do? First, find the total energy received by the solar panels of the total area of 12 meter per second. Okay, 12 meter square. So 12 meter square times 0. 85, okay? Or wait, let me do it in the other way. Wait. So when let's do it in the other way in the cross multiplication. Okay, so when 1 meter square energy is produced, receive energy of 0.85 kilojoule. Okay, so hence 12 will have x. So the x will be 12 times 0.85 when we cross multiply it. Okay, and the answer will be that we check it in the calculator. 12 times 0.85. So it's 10.2. It's 10.2 or 12 meters square. Okay, energy is received. This is the 100%, while its efficiency is 16%. So it means 16% of 10.2. So 10.2 times 16% means 16 upon 100. So the efficiency will be 16. Okay, 10.2 times 16 upon 100. So the answer is 1.6. 1.6. So let's check it in the, yeah. Okay, yes, it's here. 1.6 kilowatt. So the sixth answer is A. Let's choose 7. The work done by force F on a body is calculated by multiplying F by a quantity Q, right? Okay, what is Q? So it is velocity is not included. I think it's the same question repeated. Yes, it's the same question we have done. And its answer was A, hence it will be A. Right. Let's move on to yes, it is. The same question. Let's do the this. A girl lifts an object of mass 1 kg from the floor and puts it on a ledge 2 meters above the floor. Okay. How much potential energy is gained by the object? So in this energy, in this, what is given to us? Mass is given, which is 1 kg. Yes. And the height is given, which is 2 meters. Yes. And and here the gravitational field strength is also given, which is 10 Newton per kg. Right. So we have to find the potential energy gain, means the gravitational potential energy, because it's elevating. Hence, there will be gravitational potential energy stored because gravitational potential energy is the energy stored by virtue of its height. Okay, okay. So let's calculate it. So gravitational potential energy or potential energy will be mgh, right? Its formula is mgh. So mass is 1 kg times height, gravitational field strength is 10 and height is 2. So the answer is 20 joules. Okay, energy is stored in the. So let's check. It's 2.0. Okay, okay. So not this one. It's 5.0. Not this one. And it's C is 10 joules. So and yes, G, which is 20 joules. Okay, so for now today, guys, we have covered 8 questions of the past papers 2021 of in June and November, which were tested in the in 21. Okay, and these are these are the total questions which were asked in 2021 in June and November of the chapter work, energy, and power. Okay, energy, work, power. So that's it for today, guys. I hope you are doing well and Allah Hafiz, and do pray for me because my exams are getting there. And that's it because we have just completed this chapter. Hence, I wanted to do some past papers of this chapter so that we can have some practice about on this chapter. And most of the students forget to do the past paper, which are very important. And these past paper are frequently asked in the papers, in the school papers, and also in the main CAIE paper. Okay, so that's it for today, guys. Allah Hafiz.